This is our planet. A planet of water, rock, air, and life of all kinds. We don't just live on this planet, we're a part of it. And it is part of us. Without Earth, life could not exist. But without life, Earth wouldn't be anything like it is now. It would probably be more like Mars or Venus. Life is as much a part of our Earth's composition as are rocks and water. How did Earth give rise to life? And how did life first change the Earth? About 5 billion years ago, the Earth formed from a spinning cloud of dust, the inner ring of what would later become our solar system. A unique set of conditions, the minerals and the dust that form the planet, the size the Earth became, its distance from the sun, all these combined to make life possible. As the dust gathered, heavier elements like iron and nickel and radioactive material sank to the center, forming the core. Lighter materials rose to the top, forming the crust. The heat from the core kept the crust in a constantly changing state, just as it does today. As that early Earth formed, the intense heat released gases that had been locked in the growing Earth. Some of the gases, like oxygen and hydrogen, combined to form one of the most fundamental requirements for life: water. And because the Earth was just the right distance from the sun, liquid water could exist. The first oceans began to form. Carbon combined with oxygen to form carbon dioxide, and other gases accumulated. The very beginnings of a protective atmosphere that could retain the water. Due to its size, the Earth had enough gravity to hold on to its new atmosphere. And with an atmosphere and liquid water, life was just a short step away. The record left in the rocks suggests that the first life began in the ocean about 4 billion years ago. First, probably just self-replicating molecules, then tiny single-celled bacteria. Some of these early bacteria caused sediment around them to bind into a thin mat. And these mats piled up on top of each other. The chemical reaction of the bacteria and the water created lime. And this lime cemented the mats together, forming mounds. Mounds that are called stromatolites. Stromatolite fossils are amongst the oldest known convincing evidence of life on Earth. Today, living stromatolites in Australia look much as they would have looked 3.5 billion years ago, giving an idea of what the world must have looked like in those distant times. All life needs energy. Some kinds of bacteria began to process light from the sun to produce energy. And this process, photosynthesis, created oxygen as a byproduct. Today, blue-green algae, which are actually bacteria and not algae, function in the same way. As masses of bacteria photosynthesized, they generated more and more oxygen. And this new oxygen altered the environment of life and the surface of the Earth itself. Oxygen in the atmosphere became sufficiently concentrated to block ultraviolet light, which can be damaging to living things. Oxygen combined easily with minerals at the Earth's surface, quickening the pace of erosion. It also combined with iron dissolved in seawater to form massive deposits of iron ore. Already at this earliest time in Earth's history, life was shaping the planet, as the planet was sustaining life. Between 1.5 and 2 billion years ago, a new kind of cell appeared. These new cells, called eukaryotes, were the first complex one-celled organisms. They had a nucleus and other more complex parts that allowed them to divide more precisely and recombine with each other and produce more variations. The first multicellular life, plants and animals, evolved from some of these one-celled eukaryotes, perhaps around 1 billion years ago. Rising levels of atmospheric oxygen, changes in ocean chemistry and global climate, and changes in the genetic structure of organisms now set the stage for the Cambrian Explosion, the major diversification of animal life, which began about 544 million years ago. The mural you walked past as you entered the museum contains 544 tiles. Each tile represents 1 million years since the dawn of the Cambrian period. If you were to make a mural like this with a tile for every million years since bacteria first appeared in the ocean, you would need more than 3,500 tiles. And you would need 4,600 tiles to take you back to the Earth's beginning. Such a mural would be almost a mile long, and thus the time that complex life has existed on this planet is relatively brief. How have Earth and life changed together through history? How do we understand their complex and ever-evolving interactions? That is what this museum is all about.